Okay, today we're going to talk about inverse trig functions. This topic can get kind of detailed at times, so I'm going to kind of go kind of slow, and hopefully you guys can refer back to this video if you need to. If you're listening to this in class, maybe you can just put in some earbuds as to not disturb your neighbor, or watch it with a neighbor so there's not so many going at the same time. But we're going to pause during the video and maybe work on some practice problems. So our objectives for this lesson are to first define inverse trig functions. Second, to understand the domain and the range of inverse trig functions. We've been studying domain and range all year long, and this is an important concept when it comes to these functions because the domain and the range have to be defined very specifically in order for the inverse to exist. Then we're going to use trig functions, inverse trig functions with angles on the unit circle and with angles not on the unit circle. I think you guys will find the ones on the unit circle a little bit easier than those that are not on the unit circle. Then we're going to solve composite trig and inverse functions, and then we're going to learn to use the calculator. So the first thing is to look at the sine inverse, sometimes written as sine to the -1 and sometimes written as arc sine. If you see all of those notations, it's the same thing. So first, let's take a look at our sine graph. We're going to look at a couple questions regarding this sine graph. First of all, in order for an inverse to exist, the function must be 1-to-1. We defined that a while back. Do you remember what a 1-to-1 function is? Is this sine function 1-to-1? And we had a test to know whether it was 1-to-1. Does anybody remember what it was? It was called the horizontal line test. So if I draw a horizontal line through the sine graph, this graph actually fails the horizontal line test because a horizontal line crosses the graph more than one time. So the problem is this function is not 1-to-1. Now we just said a few minutes ago it had to be 1-to-1 for the inverse to exist. So at this point you might be asking, well, Mrs. McBride, if the sine function is not 1-to-1, how do we find the sine inverse? Well, that's actually an easy concept. We can restrict the domain on the sine function in such a way that we capture all the values of the range and still keep intact a 1-to-1 function. So the domain of the sine function right now we know to be -infinity to infinity. It goes on forever and ever, left and right. And the range is currently -1-to-1. Now we know that changes if we shift it up or down or change the amplitude, but for our sine function, the range is -1-to-1. If we restrict the domain to be between -pi/2 and pi/2, so let's highlight that, does that change the range? What's the lowest y value on that yellow interval, and what's the highest y value on that yellow interval? The range is still -1-to-1. Now, if the graph is restricted to just the yellow highlighted part, does this now pass the horizontal line test? Yes, it does. So by restricting the domain to -pi/2 to pi/2, we can now call this a 1-to-1 function and still hit all our possible y values between -1 and 1. So let's summarize what we found. A function must be 1-to-1 for the inverse to exist. If we restrict the domain of the sine function to -pi/2 to pi/2, we create a 1-to-1 function without affecting the range. Inverse functions are reflections over the line y equals x. In other words, x and y values are switched, thereby switching the domains in the range. we can get a good idea of what the functions look like below. We restricted it, in this case, to the blue graph, and the y graph is a picture of the sine inverse function, which would switch the x and the y values. Okay, we're now ready to define our inverse trig functions. I've put two definitions here. One uses the notation sine inverse, and one uses the arcsine notation. So let's first look at this sine inverse. Y equals the sine inverse, and notice I'm not reading it sine negative 1. Y equals sine inverse of x if and only if y equals the sine of x and y is between negative pi over 2 and pi over 2. And x is between negative 1 and 1. Now, notice we restricted the domain on the sine function to be between negative pi over 2 and pi over 2. Here, on the sine inverse function, it's the range because we took the inverse function, which switches the domain and the range. So the range is restricted to be between negative pi over 2 and pi over 2, and the domain between negative 1 and 1. And then the following is really the same definition, but just using the arcsine notation. Okay, so we're going to go a little quickly here with the cosine graph. Same idea, okay? Similar to sine, we need to restrict the domain of the cosine function in order to make it 1 to 1. Now, we can't use the same restriction as we did with the sine. Look here, if I restricted this to negative pi over 2 to pi over 2, does that capture the whole range? No, right? We're only looking, if I restrict it from negative pi over 2 to pi over 2, we're only looking at 0 to 1 on the range. So that's not going to work. So instead, we restrict it to 0 to pi. If I highlight that yellow part of the graph, now I've captured all of the range values from negative 1 to 1 and created a 1 to 1 function. So now we can define our cosine. Our cosine inverse, notice the y values are between 0 and pi, and the x values between negative 1 and 1. We restricted the range. Remember, we restricted the domain of the cosine, which restricts the range of the inverse. And then here's the same notation in arc cosine. Lastly, we're going to look at tangent. Same idea, we need to restrict the domain of the tangent function. Tangent function's really easy. We just look at that first period, okay? The first period of the tangent function's from negative pi over 2 to pi over 2. We restrict that, we capture all of the range values. By the way, the range values here are negative infinity to infinity. So here we go, our tan inverse. Y equals the tan inverse of x if and only if y equals the tan of x, and y is between negative pi over 2 and pi over 2, and x is between negative infinity to infinity. And then we can also see we can use the arctan notation instead of the tan inverse. Okay, so let's look at inverse functions on the unit circle. If someone came up to us and said, what is the sine inverse of square root of 3 over 2? The first thing we have to understand is, what is this problem asking us for? So this is kind of the wording that should go through your head. When we ask sine inverse of square root of 3 over 2, we're asking what angle between negative pi over 2 and pi over 2, because remember, that's the range of the sine inverse. What angle between negative pi over 2 and pi over 2 has a sine equal to square root of 3 over 2? So let's pop up a unit circle here, and I'm going to highlight negative pi over 2 to pi over 2. Okay, so I'm looking for an angle, and anytime I'm asked for sine inverse, I'm looking in this range. I'm looking for an angle between negative pi over 2 and pi over 2 that has a sine that's equal to the square root of 3 over 2. Well, there it is right there. It's pi over 3. Pi over 3 has a sine of square root of 3 over 2, so that's my answer. The sine inverse of square root of 3 over 2 is pi over 3. Now remember, this problem could have also been written arc sine of square root of 3 over 2. You'll see those notations interchangeably. Okay, let's get a little more complicated now. Sine inverse of negative square root of 3 over 2. So what is this asking us? Okay, same question. When it's sine inverse, what angle between negative pi over 2 and pi over 2 has a sine equal to negative root 3 over 2? Popping up a unit circle, highlighting negative pi over 2 to pi over 2. What angle are we looking at now? We're now looking at what seems to be 5 pi over 3. Okay, but here's where sine inverse gets complicated. The angle has to be between negative pi over 2 and pi over 2. 5 pi over 3 isn't there. Remember, 5 pi over 3 in standard position is not really in the yellow region. So what we have to do, instead of marking it 5 pi over 3, we have to call it negative pi over 3. Pi over 3 is in the first quadrant. Negative pi over 3 is in the fourth quadrant. Remember, this could have also been written arc sine. So you have to remember, when it's in the fourth quadrant, you're using the negative angles. Okay, so let's look at cosine inverse of negative 1/2. What is this asking us? Now remember, the range of cosine inverse is different. It's 0 to pi. So it's saying what angle between 0 and pi has a cosine equal to negative 1/2. So again, we'll pop up a unit circle. I'm going to highlight 0 to pi. What angle in there has a cosine of negative 1/2? Right there. Your answer is 2 pi over 3. Okay, cosine does not get complicated. Cosine, whatever angle you find, that's pretty much your answer. It could have also been written arc cosine. Now let's look at another one. Let's look at a tan inverse problem. Tan inverse also has a range of negative pi over 2 to pi over 2, like the sine does. So it does get a little complicated when you're in the fourth quadrant. So what is this asking us? This is asking us what angle between negative pi over 2 and pi over 2 has a tangent equal to negative 1. So again, let's pop up a unit circle. Let's highlight negative pi over 2 to pi over 2. Where's the tangent negative 1? Right there. So now once again, just like sine, we don't want to write 7 pi over 4, because 7 pi over 4 is not between negative pi over 2 and pi over 2. Negative pi over 4 is. Now you can tell where I'm recording this, in my classroom. Negative pi over 4 is between negative pi over 2 and pi over 2. So we don't want to use 7 pi over 4, we want to use negative pi over 4. Okay, at this point, if you have your classwork number 11 in front of you, you might want to pause the video and work on questions 1 through 6. If you'd like to continue watching the video, you can, but to keep it fresh in your mind, you might want to work on 1 through 6 right now and then resume the video. Okay, so now let's talk about composite functions. Example 5. Composite functions, remember, when you have one function nested within another. This reads, find the exact value. So usually when it says exact value, it means you're not using a calculator. Find the exact value of the cosine inverse of the cosine of 7 pi over 6. Okay, it looks complicated. But let's keep in mind that according to PEMDAS, we do the inner parentheses first. So we're going to do this step by step. The first thing we're going to do is find the cosine of 7 pi over 6. This is not cosine inverse. This is old business. This is the cosine of 7 pi over 6. So I popped up a unit circle, locate 7 pi over 6. What's the cosine? It's negative root 3 over 2. So what I'm going to do is I'm going to replace cosine inverse of the cosine of 7 pi over 6 with cosine inverse of negative root 3 over 2. I found the cosine of 7 pi over 6 to be negative root 3 over 2, and I replaced it. Now we're back to where we were at earlier examples. Cosine inverse of negative root 3 over 2. Okay, what does this mean? Remember, what angle, cosine inverse is between 0 and pi, what angle between 0 and pi has a cosine of negative root 3 over 2? Right there. So the answer to this problem, what angle between 0 and pi has a cosine equal to negative root 3 over 2? The answer is 5 pi over 6. Okay, now you may ask yourself, wouldn't cosine inverse and cosine cancel each other out? Sometimes they do and sometimes they don't. In this case, it doesn't. And here's why. 7 pi over 6 is not in the range of cosine inverse. Cosine inverse is between 0 and pi. 7 pi over 6 is bigger than pi. Okay, it's 7, it's like pi and 1/6. It's bigger than pi, so it's outside the range of cosine inverse. When the angle is outside that range, those two are not going to cancel each other out. Let's look at another example. Find the exact value of the sine inverse of the sine of negative pi over 2. Okay, what is this asking us? Again, inner parentheses first, according to PEMDAS. So, what is the sine of negative pi over 2? Pop up a unit circle, which you really should need because you should have your unit circle memorized. But what is the sine of negative pi over 2? It's negative 1. So now what we have is we have the sine inverse of negative 1. I found the sine of negative pi over 2 to be negative 1. I replaced it, and now I have the sine inverse of negative 1. Again, we're back to earlier examples now. We're back to a simple inverse function. What angle between negative pi over 2 and pi over 2 has a sine equal to negative 1? Think about it. Think about it. Remember the range. You don't want to say, if you said 3 pi over 2, you don't want to do that. You want to say negative pi over 2. So the sine inverse of the sine of negative pi over 2 is negative pi over 2. In this case, the sine inverse and the sine did cancel each other out. Why did that happen? Because in this case, negative pi over 2 is in the range. The range is negative pi over 2 to pi over 2, including negative pi over 2 to pi over 2. So in this case, I could have just easily answered that question because negative pi over 2 is in the range of sine inverse. They cancel each other out. Okay? Now, when they're not angles on the unit circle, it's pretty icky. So let's look at example 8, and that's a technical term, icky. The sine inverse of the sine of negative pi over 10. Okay? Well, if you remember what we just said, is negative pi over 10 in the range of sine inverse? Is negative pi over 10 between negative pi over 2 and pi over 2? And the answer is yes. So this one I don't have to do any work on. If I can recognize that negative pi over 10 is between negative pi over 2 and pi over 2, these guys cancel each other out, and the answer is negative pi over 10. However, they're not all going to be that simple. So let's do the tan inverse of the tan of 4 pi over 5. Okay, is 4 pi over 5 in the range of tan inverse? Okay, some people may have a hard time picturing where that is. So we have to find out, and actually it's not, and I'll show you why it's not in a minute. But we have to figure out if it's not in the range. Time for period 6. If the angle is not in the range, then we need to find an angle that is in the range of tan inverse that has the same tangent value. So let's pop up a coordinate plane here. I didn't pop up a unit circle because this one's not on the unit circle. So where would 4 pi over 5 be located? What quadrant would it be in? Well, remember, we did this at the beginning with the unit circle. 5 pi over 5 is a whole pi. 4 pi over 5 would just be slightly less than a whole pi. So it would actually be in quadrant 2. So it would be somewhere about there where the blue line is. Is that exact? No. But that's about where 4 pi over 5 would be. Okay, now you have to ask yourself a question. You're in quadrant 2. Is the tangent positive or negative in quadrant 2? Right, it's negative. So in what other quadrant is the tangent negative? Because we have to find another angle that has the same tangent. So if this tangent's negative, I've got to find another quadrant where I have a negative tangent. Well, it's not in the first quadrant because everything's positive. The third quadrant, tangent's also positive. Remember, you're all students, take calculus. So therefore, it must be in the fourth quadrant. And that makes sense. Let me pop that back up. That makes sense since the range of tangent is tan inverse is between negative pi over 2 and pi over 2. Our angle must be in quadrant 4. It would also have a negative tangent in quadrant 4. And that is in that range of negative pi over 2 to pi over 2. So the question is, what would that angle be? That angle would actually be negative pi over 4. Remember, for sine inverse and tan inverse, if you're in the fourth quadrant, you're looking at the negative angle. Now, how did I come up with negative pi over 5? Okay, think about this. What do 4 pi over 5 and pi over 5 add up to? A whole pi, 180 degrees, right? When I put those two terminal sides together, what do they form? Think about it. They form a line. So 4 pi over 5 and pi over 5 make pi, which is 180 degrees, which is a straight line, which is also the period of tangent. It's a lot to take in, but it really does all fit together. Okay, let's look at another one of those. The sine inverse of the sine of 8 pi over 7. Okay, same deal. Is 8 pi over 7 in the range of sine inverse? Well, the range of sine inverse is negative pi over 2 to pi over 2. Obviously, 8 pi over 7 is bigger than a whole pi, right? So it is bigger than pi over 2. So let's figure out an angle that would have the same sign. So, whoops. So I popped up a coordinate plane. What quadrant would 8 pi over 7 be in? Well, like we just said, 8 pi over 7 is a little more than pi. So it would be in quadrant 3. Okay, so now what's the sign in quadrant 3? Not the sign, but the sign of the sign. Is it positive or negative in quadrant 3? The sign is negative in quadrant 3. So what other quadrant do we have a negative sign in? It would be quadrant 4. Okay, because quadrant 4 is in the range of sine inverse. It's between negative pi over 2 and pi over 2. So what is that angle? You guys are going to start to see a pattern to this. That angle is negative pi over 7. It's negative pi over 7. Now, those do not add up to 180 degrees in absolute value because it doesn't form a straight line. Okay? But you can notice the distance, 8 pi over 7 is 1/7 more than a whole pi. It's pi over 7 more. So I just have to go pi over 7 the other direction. The answer to this problem is negative pi over 7. Those are probably some of the most difficult problems. You won't see too many of them on your homework, but you will see some. Okay, so if you want to pause the video here and take your classwork number 11 and work on numbers 7 through 12, you can do that. I'll also be leaving a key, so you can also check the key to make sure that you're doing it right. So pause the video now and do numbers 7 through 12 on classwork 11. Okay, so last thing, and this will go quickly now, make sure we're going to do calculator work. Make sure your calculator is always in radian mode. So hit the mode button on your calculator, arrow down to where it says degrees and radians, and make sure radians is highlighted. Okay, that is really the big key here. And try to input these. Do sine inverse of negative 1/3. To get the sine inverse button, it's above the sign. So it's a yellow function, so you have to hit the yellow second button first, and you'll see sine inverse pop up of negative 1/3. And you should get 0.339 radians. Okay, you're getting the angle. What does that mean? It means an angle of 0.339 radians has a sine of negative 1/3. Your calculator is already programmed. It will look between negative pi over 2 and pi over 2 for sine and tangent. It will look between 0 and pi for cosine inverse. That's the great thing about the calculator. It's already programmed to do that for you. Okay, so now try cosine inverse of negative 1/4. You should get 1.823 radians. Okay, 1.832 radians. Now that I'm thinking about it, sine inverse of negative 1/3 may not be right. It's not. My first one is incorrect. I think I did 1/3. The sine inverse, of course I made a mistake. This long video and I make a mistake. It's negative 0.339. Negative 0.339. Please make that correction. The sine inverse of negative 1/3 is negative 0.339. And it makes sense because if it's got a sign that's negative, it's got to be in the 4th quadrant. So it's got to be a negative angle. Okay, sorry about that. Sine inverse of -2. Type that in your calculator. What that is asking you is what angle between negative pi over 2 and pi over 2 has a sine equal to negative 2? What angle between negative pi over 2 and pi over 2 has a sine equal to negative 2? Think about your unit circle. We're even not putting in the calculator. Think about your unit circle. Is sine ever negative 2? No, it's undefined. Sine is a range of negative 1 to 1, which means arcsine has a domain of negative 1 to 1. The sine never gets bigger than 1 or less than negative 1. So there is no such angle that has a sine of negative 2. So if you got an error in your calculator, that's why I tricked you. Okay, so here's what you have now. You can finish classwork number 11. Make sure you turn that into your row folder. Then you can work on homework number 13, which is page 450, number 13 to 43. Hope that wasn't too long. Hope it wasn't too confusing. And we'll talk about it at our next class.